So we're looking at cryptarithms today, which are the ultimate column addition problem. Let's go straight into the questions and we can have a look at these. So here are the 4 questions we're going to look at, and I'll explain how they work. So if we take number 1, each letter stands for a digit in the number. So you've got A plus A plus A plus A, and these are all addition calculations as well. I'll just put the plus sign there, and you can see that with each question it resets. So the A on question 2 will not be the same probably as the A on question 1. And you can see we've got 3 A's added together, and the answer has to be BA. And we have to work out what is A, what is B. So just to help me out, I'm just going to maybe use a different color and draw just another one of these at the side, so I can kind of like work through it, try some things. If they don't work, I can alter them, and then hopefully land upon my final answer. So here we've got 3 single-digit numbers, and it's really important to pay attention to whether these are single-digit, 2-digit, 3-digit numbers. They're 3 single-digit numbers added together, and they're going to go into a tens number because we have a tens digit in the answer. And most importantly, the single digit reappears in the answer here. So if I just try 2 add 2 add 2, then that's obviously not going to work because we're going to get 6. We're not even going to get a tens digit here, so we don't want to do that. Maybe let's try something like 4 add 4 add 4. Well, that's definitely going to get us a number with a 10 in it. So 4, 8, 12. So we've got 12. Well, that gets us B equals 1, but we don't get A reappearing here. So these 4 digits all need to be the same. So now I might try, well, we've got 6, 12, 18. That doesn't work. 5, what have we got there? 5, 10, 15. Yeah, that will do. So 5, 10, 15. We can see that A must be 5 and B must be 1 to give us 15. So that one works. So let's have a go at number 2. Again, I might move this across a bit. I'm going to just do myself a kind of rough column here so I can just have a go and play with this a little bit to find the answers. And here, if we look at the structure again, we have a 2-digit number, and it's the same digit, plus a 1-digit number is going to give us a 3-digit number. So that gives us some clues, and we can use that logic to help us at least give us a kind of path to try some different numbers. Now, if I've got a 2-digit number adding to a single-digit one, and it goes into the hundreds, if this was like 80, let's just say like an 89 or something, then the maximum single-digit number I have is 9, and that's just going to give me 98. I'm not going to get into the hundreds. So I'm thinking that this B must be 9. Must be 9. Because that's the only way that we can add a single digit number to it and get it into the hundreds. So if B is 9, so A can't be 9, it's got to be something else. And if we have 99 and we're going to get into the hundreds, then we can't have a 200 number or 300 and something. It must be 100 and something. So now I'm thinking, well, this A must be 1, right? And if this A is 1, well, then this A is also 1. We've got 99 add 1 is 100, and that works. So B must be 9, A must be 1, and C is 0. Okay, on to question number 3. Let's move this down a little bit. Let's do that. Again, I'm going to have a little rough area for working here, and we're going to have a look at the structure of the problem. So we've got AB plus A, and again it goes into a hundreds number. So if we're adding a single digit to get into the hundreds, this can't be 8 or 7 or 6, this must be 9. And so if this is 9, well then the other A must be 9. And now we're thinking about B. Again, we've got this CC. So I'm thinking, is this 100? So if we could try that, maybe we've got 91, add the 9 gives us 100. and then we get the 100 there, and that will work. You could also think about it that B must be 1, because if we have a 2-digit add a 1-digit number, we're only going to have 100 and something. We can't have 200 or 300. So we also know that B must be 1 from that. And then we can put the 1 in there. 91 add 9, it's going to be 100. A is 9, B is 1, and C is 0. Right, on to the last one that we're going to sort of walk through slowly. And we've got AB plus A equals CDC, so slightly different. Same format with the 2-digit, add the 1-digit, giving us a 3-digit number as the total. So again, I'm thinking this must be 90, because if we're adding a single digit to it and we're getting into the hundreds, we can't have 80 or 70 here. And now I'm also thinking, well, it must be the 100s, right? Because we can't, again, do 9, say if it was, even if it was 99 add 9, it's still going to be 100 and something. So these two must be 1. And now I'm thinking, okay, I need something like, well, 101. Would that work? So if D was 0, then I'm going to need 92. Plus 9 is going to give us 101, and that one would be correct. So A must be 9, B is 2, C is 1, and D is 0. And that gives us 92 plus 9 is 101. Right, now it's your turn to have a go. So these are 4 other cryptarithm problems for you to have a go at. They're slightly more challenging. You might have to play with them a little bit. Have a go at them, and then we can go through the answers in a second. Okay, let's have a look at these. So we have AB plus BC equals BCB. Again, if we've got our two-digit numbers, even if we have like 99 and 99, we're still going to be, answer is going to be 100 and something. So straight away, I am thinking that B must be 1. So I've got 1, 1, and I've got a 1 up there. Right, okay, so, oh, sorry, and I've got a 1 here. Now, if we're going to get into 3 digits, A must be 9. So we've got this 91 plus something. And, I mean, maybe if we have 90 plus 10, it's going to give us 100. So maybe if this is just a 0, yeah, that will work. We have 90 plus 10. Gives us 101. So there we have A is 9, B is 1, and C is 0. On to question number 2. We have AB plus CB equals BBA. Right, okay, BBA. Again, I'm thinking this must be, B must be 1, because we're only with 2 two-digit numbers, we can only have a 100 and something. The 2 biggest 2-digit numbers, if we did 99 and 99, 198 would be the result. This would still be 1. So if that's 1, then these other B's must be 1. Here's a clue. We've got 1 plus 1 in the units here. We could just do the answer to that, which would be 2. So we've got a 2 here. And if we want this to make 112, then what do we have to add to 21? So in my head, I might do 112 take away 21. Which is going to be, so it's 92, 91. And let's just check that that works. So 90 add 20 is 110, add the 2 is 112. So that one works. So if you have the 2 digits, you can just add them up going down if they're in the same column. So for this one, we've got A is 2, B is 1, C is 9. Let's have a look at number 3 and number 4. I'll just move it down slightly. So with number 3, we also have the same format as we have 2 two-digit numbers that make a 3-digit number. So we must have C equals 1. But this only helps us with the 1 digit here, right? We can't sort of work out anything else. The units are a bit tough. I mean, we've got 2 different units, digits that add up to make something different as well. So maybe I might look at this tens and see if that helps. So we've got a plus a, and it gives us a in the tens. But we also need a carry because we've obviously got the 100, right? So it must be, so if we did something like 6 and 6 would make 12, right? And that doesn't really work, because even if we had a carry here, we'd only be able to get this to 3, and we need this to be the same. So I could try some of those. If we did 7 and 7, that's going to be 14, even with a carry only 15. 8 plus 8 is 16, with a carry at the top would only be 17 as well. So how about 9 and 9? That looks the most promising, which is going to be 18. If I had a carry as well, I can make that 19. So that would work with the A. It would also mean that this is now 9. So in order for this to work, we just need B and D to give us that carry. And obviously they can't be the same, and they can't be the digit 1 or the digit 9, because we've already used those. So actually, there's a few different options you could have for these. So we'll just go through them. You could have 1, and that would give you a 0. That would work. You could have 9 add 2 is 11. Oh, that wouldn't work because you've got C is already 1. So you can't have that one. 9 and 3 gives you 12. That would work. 9 and 4 gives you 13. That would work as well. 9 and 5 would give you 14. That works too. 9 and 6 gives you 15. That works as well. 9 and 7 gives you 16. 9 and 8 gives you 17. That works too. And we obviously can't have 9 and 9 because we've already have a 9 digit for A. So there's a few different options there, which is great. And if you got them all, well done. And let's move on to question number 4 now. So this is an interesting one. You have 4 2-digit numbers, and they're still adding up to a 2-digit number, so we're not going into the hundreds. All the tens are the same, all the units are the same, and the tens digit is in the answer here on the unit side. And this sort of answer digit here for the tens is different too. So I might just do a little bit of trial and error and just see if I can, work out something that will sort of work with this. If I'm looking at these tens here, if they're, let's just say, if they're all 1, then this is going to be a 4. I need this to be a 1. So I'm thinking, well, what could B be so that it gives me a 1 as the answer? And it probably needs to have a carry, because obviously even if it was all 1, so maybe there's a carry at the top, and then this is a 5. Could that work? Let's have a little look. So then we need 11, but it's got to be made up of 4 of the same number, so we can't make 11. We can't do the 11 divided by 4, so that isn't going to work. So now maybe if these are all 2s, 2, 4, 6, 8. Let's have a go at that. 2, 4, 6, 8. So this would have to be 2. So that would involve a carry, making this 9. And can we have 1, 2, 3, 4 of the same that make 12? Well, 12 divided by 4 is 3. So can we have 3, 6, 9, and 12? So that gives us our 12. And then 2, 4, 6, 8, add 1 is 9. Yep, that works. So we've got A is 2, B is 3, and C is 9. And I think if that didn't work, I would then try 3 in this column here. So we could have a quick look at that. So if we had 3, 6, 9, 12, that becomes a problem then. So if we go further, we then get into the hundreds. So we can actually only have a tens digit, which is 2 or 1, without then going into the hundreds, which we can't do. So those are the 4 questions. I hope you did well with those. And as a last part, there is an extra challenge with this calculation: AB equals CA. And there's 4 possibilities for that. Can you find all 4? Thank you for watching, and check out the Descent Learning channel for more maths videos.